Could this strange material replace powder in metal 3D printing? I'm Stephanie Hendrickson with Additive Manufacturing Media, and these are samples of a material produced by Adicote. Adicote is a spinout from Trinity College Dublin, where two researchers developed this material, which is a flexible metal-polymer composite. This is metal additive using polymer sheets, or MAPS. The material is made through solvent casting of metal powders with polymer and some other additives. This sample contains titanium powder and this one contains copper powder. But you can use many different alloys, even different particle sizes and morphologies to manufacture these sheets of material. The material can be produced in long rolls up to 30 meters or longer, and you can tune the thickness of the sheet for whatever the application or need is. So what can you do with this material? One possibility is to use it as a coating. The sheets can be cut to size, placed onto a part that you want to cover, whether it's 3D printed or not. You can hold it in place with a heat gun, and then you need to sinter it to remove the polymer binder and leave behind just the pure metal powder. You can do that sintering either with a laser inside of a 3D printer or in a furnace. This technique could be used to improve wear resistance, control tribological performance, or just improve the surface finish of the part. Coating can be applied only in the places that you need it, and any leftover cutoff material can be reused or recast into a new sheet. But another possibility for MAPS would be to use the sheets as a replacement for the powder bed in laser powder bed fusion. So instead of a laser powder bed fusion machine where you're scraping or brushing loose material across the build plate, imagine a setup where you've got rollers on either side advancing a spool of this material. So the material covers the build plate, laser turns on to draw the cross-section of the layer, and then the roll advances to provide a clean sheet of material to begin the next layer. Using rolls of this material as feedstock would eliminate many of the material handling challenges with laser powder bed fusion currently. There would be no sieving, fewer PPE requirements, while still enabling recycling by recasting the scrap material into new sheets. It would also enable much easier changes between materials. You just have to swap out the roll without cleaning the entire machine, as well as multi-material 3D printing. MAPS could even be used to enhance parts during printing without additional process steps. A small amount of carbon in the sheet, for example, could be engineered to alloy into the metal during solidification, which means you could apply surface hardening right inside of the printer. So how is MAPS being used right now? So Adicote has developed a manufacturing process for making these long sheets of material, and they've experimented with a number of different alloys. They've done some successful testing of this material as a coating for implant surfaces in laboratory trials, as well as some other use cases. They've also worked on using the sheets in a roll-to-roll style for laser powder bed fusion. Researchers have collaborated with the Irish Manufacturing Research, or IMR, Institute to modify a machine for this purpose and study the different parameter settings and effects that might come from 3D printing with MAPS. So what do you think? Would you like to replace your powder bed with powder sheets? For more information on this technology, we've got links to the company's website, research studies, and more in the show notes. And for more 3D printing materials, processes, and applications, follow Additive Manufacturing Media wherever you're watching right now.